What if the future of computing doesn't run on electricity at all? For more than 50 years, every computer, smartphone, and AI system has relied on the same basic idea: electrons flowing through silicon. That simple principle built the digital world. It gave us the internet, modern software, and artificial intelligence. But today, that same foundation is becoming a serious limitation. AI is growing faster than our hardware can handle. GPUs are running hotter. Data centers are swallowing massive amounts of electricity. And no matter how advanced our chips become, physics keeps reminding us of a hard truth: electrons can only move so fast. So engineers are exploring something radical. Instead of pushing electricity through transistors, they're using light itself to compute. No electrical resistance, no overheating bottlenecks, just photons carrying information at near light speed. This isn't science fiction. It's already happening, and it could redefine the future of AI forever. The problem with the electrons. To understand why computing with light matters, we need to understand what's breaking. Modern AI runs on GPUs packed with billions of transistors. Every calculation depends on electrons moving through microscopic circuits. As chips shrink, those electrons generate more heat, lose more energy, and slow everything down. Training a single large AI model can consume as much electricity as thousands of homes. Entire data centers are now limited not by intelligence, but by cooling systems and power grids. This is the wall silicon is hitting. No matter how small transistors become, electrons still face resistance. They collide with atoms. They generate heat. And they impose a speed limit that can't be engineered away. That's why researchers are asking a dangerous question for traditional computing. What if electrons aren't the future at all? What if light is? How light can actually compute? At first, the idea sounds impossible. Light doesn't weigh anything. It doesn't slow down. So how can it do math? The answer lies in how light behaves. In photonic computing, information isn't stored as electrical voltage. Instead, it's encoded into light itself. The phase, intensity, or timing of a laser pulse represents a number. When two beams of light intersect, something incredible happens. They interfere. Their waves add together. They subtract. They amplify or cancel out. And that interaction performs real mathematical operations. This is the same math that powers artificial intelligence. Matrix multiplication, vector operations, the core calculations behind neural networks. Instead of forcing electrons through billions of transistors, photonic processors let physics do the work naturally. Calculations happen at the speed of light with almost no heat and dramatically lower energy loss. In other words, light doesn't just carry data, it computes. Optical neural networks and the AI revolution. Now imagine building an AI chip around that idea. Optical neural networks replace traditional transistors with photonic circuits, waveguides, mirrors, splitters, and modulators etched directly onto a chip. As laser light passes through these structures, it automatically performs the same operations a neural network needs to learn and reason. No clock cycles, no electrical bottlenecks, no overheating GPUs. Just photons flowing through carefully designed paths. Companies like Light Matter and Light Intelligence are already building these processors. Early results show massive gains, orders of magnitude faster training speeds with a fraction of the power consumption. This could change everything. Data centers that no longer melt the power grid. AI systems that train in hours instead of weeks. Intelligence that scales without destroying energy infrastructure. And most importantly, it breaks the dependence on silicon. For the first time in decades, computing has a new direction forward. Not faster electrons, smarter use of light, real companies, real hardware. This isn't just a research experiment. Companies like Light Matter and Light Intelligence are already building commercial photonic processors. These chips integrate optical computing directly into existing data center infrastructure. They don't replace electronic systems entirely. Instead, they accelerate the most computationally expensive parts of AI workloads. Major tech companies are watching closely because whoever masters photonic computing first gains a decisive advantage in artificial intelligence. The future of AI computing. Optical computing won't replace silicon overnight. But as AI continues to scale, hybrid systems combining electronics and photonics may become the new standard. In the future, data centers may glow not from heat but from light. AI models could train faster, cheaper, and with far less environmental impact. Entire new architectures may emerge, designed around photons instead of electrons. This isn't just faster computing. It's a new way of thinking about computation itself. The story of computing has always been about overcoming limits. Vacuum tubes gave way to transistors. Transistors shrank into silicon chips. And now, silicon itself is reaching its edge. Optical computing represents more than just faster hardware. It represents a fundamental shift in how we think about processing information. By letting physics do the math, photonic systems open the door to AI models that train faster, consume less power, and scale beyond what electronic systems can realistically achieve. If you enjoyed this deep dive into one of the most important technological transitions of our time, support the channel by liking the video, subscribing, and turning on notifications. Here on Top 10 Explorer, we break down the ideas shaping tomorrow's world clearly, deeply, and without the hype. Until next time, keep questioning, keep learning, and keep exploring the future.